ever wondered how water flows effortlessly through pipelines, irrigates fields, or power industries? Meet the centrifugal pump. From homes to factories and from power plants to water treatment facilities, centrifugal pumps are at the heart of countless applications. In this video, we'll dive into the world of centrifugal pumps, exploring how they work, their key components, and why they are widely used in multiple industries. Whether you're an engineer, a student, or just simply curious about how technology drives our world, this is your ultimate guide to centrifugal pumps. So, without further ado, let's get started. What is centrifugal pumps? Centrifugal pumps is a type of pump commonly used to move a fluid through a piping system. It works by converting mechanical energy from an electric motor into kinetic energy and then into pressure energy to move the fluid. This process makes centrifugal pumps ideal to transfer a large volume of liquid efficiently.
A centrifugal pump consists of several key components that work together to ensure efficient fluid transfer. First, we have the suction pipe and inlet, which guide the fluid into the pump while using a strainer to prevent debris from entering. The impeller is the heart of the pump, transferring energy to the fluid by increasing its velocity. Next, the casing houses the impeller, protects the internal components and ensures the fluid flows smoothly. The diffuser slows down the fluid to convert its kinetic energy into pressure energy, increasing efficiency. The discharge pipe and outlet allow the fluid to exit the pump while minimizing pressure losses. Supporting this component, we have the drive shaft, which connects the motor to the impeller, and the packing, which prevents fluid leakage. Lastly, the diffuser plates evenly distribute and regulate the fluid flow. Each part plays a crucial role in ensuring the pump operates effectively and efficiently. The operation of a centrifugal pump begins with fluid entering the pump through the suction side, flowing toward the impeller. As the impeller spins rapidly, it adds velocity to the fluid, converting mechanical energy into kinetic energy. The high-velocity fluid then exits the impeller and enters the casing, where it slows down and converts this kinetic energy into pressure energy. Finally, the fluid is discharged through the outlet at a higher pressure, ready for use in the system. This principle ensures an efficient transfer of fluid from one point to another.
Okay, now I will explain to the application of a centrifugal pump in modern industry, which are chemical, food, and oil refining industries. In chemical industry, the centrifugal pump used for transferring corrosive, hazardous, and highly viscous fluids to another area. It can vary their flow rates but based on system resistance, which in turn make them more energy efficient. Steady flow are very much needed in this sensitive process, with minimized pulsation when precise, as the fluids are highly corrosive and viscous. Meanwhile, in food industry, centrifugal pumps are widely used in transporting liquid food with low viscosity such as juice, milk, and other beverages. In initial stages of production line like pasteurization process, they are designed to pump these fluids over long distance through pipelines, ensuring consistent pressure and homogenization of mixture to prevent product degradation by mixing liquids using a rotating impeller to convert energy into kinetic or pressure energy in the fluids. And lastly, in oil refining industry, crude oil are transferred from storage tank to various processing units to maintain high pressure during the transfer. It is separated into different fractions based on boiling points. This is to keep flow rates and pressure. These processes are used in hydrocracking, hydrotreating, and catalytic cracking. In catalytic cracking, a heavy fraction of crude oils is broken down into lighter products such as gasoline. Here are the three of the advantages that centrifugal pump can offer. Firstly, energy efficiency, which lower the cost in the short term the life cycle of each device, plus minimizing the strain of the equipment on energy systems. Next, quality, as they are durable, which can handle harsh chemicals and conditions, allowing them to transfer all kinds of liquids effectively. And lastly, it requires low maintenance by its long-lasting performance in a wide range of applications. It also minimizes parts that require maintenance or replacement. And for disadvantages, the centrifugal pump is sensitive if there is air in the suction pump, as it can break the continuous flow of liquid needed for pumping, causing to loss of suction, meaning that the pump cannot pull liquid properly, which can cause it to stop working correctly. Other than that, it cannot convey highly change factor of the liquid like the viscosity and pressure. When pumping thicker liquids, they create more resistance due to the impeller spins. If these factors change often, it becomes hard to keep the pump running effectively and avoid damage over time. And lastly, the centrifugal pump is limited to self-priming ability in order to keep a centrifugal pump working properly.
And there you have it, the centrifugal pump. A brilliant combination of science and engineering that has transformed the way we move fluids. From delivering clean water to our homes and powering industrial processes to enabling large scale irrigation, centrifugal pumps are truly at the heart of modern infrastructure. In this video, we explored how centrifugal pumps work, broke down their essential components, and looked at their many applications. Their efficiency, simplicity, and versatility made them indispensable across a wide range of industries. We also learned the disadvantages compared to the other types of pumps. So, whether you're an engineer optimizing a system, a student diving into fluid mechanics, or someone curious about the world of machines, we hope this video gave you a clearer understanding of centrifugal pumps and their importance in everyday life. And that's from us. Thank you for watching.